Welcome back. In this exercise, we're going to build this headphone stand. What is quite interesting in this demonstration I show you is how we start actually by first building a very simplistic volume study like this. And also all our sketches are really simplistic. And then in step 2, after the proportions are good, then we're going in and add all the details, rounded edges, openings, shelling the design. And I'm also going to put in existing electronic elements to suggest what type of interior would go in there. Because as an industrial designer, while we're not an electronical engineer, we can put these models in. So for example, these models I can get from GrabCAD. It's a really good website for many common elements or other suppliers. And again, for us as industrial design, this is perfect to put something in so people can understand what we mean. And also we can use other sources, Wikipedia. For example, here I just Googled the opening for the pin, etc. Or looking at some technical drawings. Okay, so with all that said, let's get going. So let's create a new design. Right click, turn off the timeline, and then settings millimeter. This headstand is very simplistic, and honestly, direct modeling is really great to use in this case. So before we get started, let me go back to this model here. And there you see, this is very simplistic. Cube, cylinder, cube, and roller coaster sweep. This is very good to model first as a proof of concept, a study. Also very fast to do. It's easy, economically good. Think about all the stuff is also what we could make it with foam very quickly. Now we will cut a block and then we start rounding the edges. So we 3D model exactly the same way. Let's go to top view. Make a sketch on the ground. I would like this one, and then that's 98 by 98. There we are. This we will extrude up 28 millimeters. Cool. Now, new sketch on top of that face. Same rectangular tool, this time a 20 by 10 rectangle. This we extrude up 230 millimeters, but as a new body. Thank you. And these two we can turn off. There, look at this. Huh? Okay. So how do we do this part? That's actually quite easy. See, this is all what we need. An arc and kind of like a track. I go to the side view. Then on the side view, I create a sketch. And this should be an arc, click, click. I click those on purpose a little bit off, so I can explain to you everything what we have here now. Left point, right point, arc, center point. The center point I would like to be vertically centered to the sketch center. There. And now these 2 points I would like to be horizontally aligned. Now all I can do is move the arc up and down and maybe make this arc bigger. With the dimension tool, these 2 points are 70 millimeter apart, and we have a radius of 80. Very good. Let's bring the body back here. This I move up. Now I would like this arc to perfectly sit on top of this face. So I need a snapping point. I can project or intersect this face with the sketch, and then you see where this intersects, it creates one intersection line. No, the arc has a midpoint. The line has a midpoint. Here's midpoint. Click, click, done. Awesome. Okay, so the roller coaster track is done. Now we have to build the cart. We could go to the side and then project this in and draw a line out. However, this is a really great situation to showcase how plane along path works. So I will create a plane along this path. And you see how we can move this left and right. There's a start, mid, and end snap point. Cool. Now, this plane is also perpendicular to that arc. So sketch on this plane. You also see that this new sketch has this 0 point perfectly sitting on this arc here already. So there's no need to make sure that the line I'm going to draw perfectly sits there on this arc. So line tool, this line is 25 millimeters, and then horizontally, and then vertically another one, 10 millimeters. I have a perpendicular constraint, that's good. Now let's go to surface, because we only have some lines. We can use the sweep command. So this profile, I have the chain here selected, otherwise I select both, along this path. There we are, done. Now this swept body, so this one here, I can mirror over the other side. I'm pressing and holding the mouse button till then I can get this interface, click YZ, join, okay, there's the body. And some dissolves. Pretty cool. Look at this, no? So that wasn't too complicated. Now you can understand if we now want to go in and say, so this is 98. What about we make this actually, we expand this by 2 millimeter to make it 100. It's very easy to do this. If I select the move copy and then I select the face, click and drag on these from left to right, now I can move all these faces up. So this whole thing was 230, maybe minus 30, so it's only 200 millimeters away from here. So you saw now this is actually super easy to do in direct modeling. And also we have a very simple geometry. I undid all the steps, so we're back to the originals, because before we continue, I would like to create a new group. And I call this one backup. And I will make a copy from all those, 3, maybe 300 millimeters to the side. So, and those I put into this backup folder. The main reason behind this is, and it's also one of the great parts of direct modeling, now I can really mess around with this one. And in case something is so damaged I can't repair it, I always have my backups left. Very good. Okay, so we have the basic part done, and now it's time to actually go ahead and start detailing. And I will show you there also how fast this goes. So what I will do now is start rounding certain elements. I select those edges here. Now this is 10 millimeters, which means I can do a fillet of 5 millimeter. And then you see I get perfect, half rounds. If I do 4 or 4.5, you see it's not really perfectly round. And 5, no, 10 divided by 2 is 5. There we are. Very nice. Cool. Now it doesn't look too bad. Let's go to the fillet here, and then we select this edge, this edge and this edge. And then we can type in 14. Very good. And before we continue, I would like to point one thing out. So when we switch this to G2, you see this actually looks much nicer. But can also be more computational intensive. And in direct modeling, we can't adjust it so easy. So as a note for those who might ask, why do I use G1? That's because of the limitation of the direct modeling. With G1, I can adjust the radius. With G2, actually I can adjust the radius too later, but it being then reset to G1. So I just go with G1 from the beginning. Okay, very nice. This is now a very sharp corner. Let's go ahead, fillet this second time, 2 millimeters. Look at this. This looks beautiful. Now, because we are in direct modeling, we can actually go ahead and say push and pull this to 1 millimeter. You see how this updated it. What about this goes, instead of 14, 10 millimeters? You see how everything else moves with it. So this is actually a really nice tool and workflow to just so freely adjust everything. This piece is actually joined onto the base. Okay, so combine, U, join, okay. Then we can go fillet, select this edge and say 5 or 2, 4, 10, 5, yeah. That's a nice transition. Also here, G2 visually will look better, but for what we do here right now, G1 is good. Very nice. Okay, since we're working on the base, we also know that this sits actually on a small element. There, now you see this. So one very easy trick is this. I shorten -2 millimeters. Thank you. Then I extrude this by 2 millimeters, but as a new body. Zuck. And by having it done this way, I didn't need to round these edges. I kind of like build this piece by simply extruding off the lower surface, which I moved up by 2 millimeters. Pretty easy modeling trick. So this is all actually pretty cool, I would say. Let's go to here. Now this is a surface. We want to turn this into something that is solid. But before I do this, these edges I would like to round. So this is important. We go fillet these two edges 5 millimeter. And now we can go ahead and thicken this 2 millimeter. This flat surface we don't need anymore. It can go. Yeah, not too bad, no? Now we can go ahead and then round this edge, and this edge, 5 millimeters. That is maybe too much. 4 looks good. And then one more fillet, 0.5, 2.5, 2.5 looks good. Beautiful. So what do we do here actually? Now we want to fuse this together. It's actually quite interesting how this can work. Before I, however, do this, I would like from this flat face, bring something down. So -10. Just a construction plane, and I will hide this for the moment. You will see what we are going to use this for. So now there are two ways how we can connect this to here. One way is, I show you way number one. Just now pay attention to it. Bring this up. There we are. So we overshoot. Then we join this together. Thank you. And then all this here, I select, press delete. It's gone. Now, one way. Now undo everything until we're back to here. This face, just to make it easier to see, I move down a little bit. And what I'm going to do now is say this face be wrapped or folded over this face. And that is the replace face command. So view, over view. There you can see now how this is bended. Now they're perfectly touching each other. And we can join those. The end result, by the way, of each method is the same. Now we can also go ahead here, select this 5mm for the rounding, done. Yeah, pretty cool, huh? Look at this. This is actually not bad. So what I'm going to do now here we have our backup stuff. All this I can select. These two bodies, make a copy, minus 150. Or what about 200? Let's see. 200 goes to there. And then these two I put into there. Okay. You notice how I'm step by step always making copies of steps when I really had like significant amount of steps done. Okay, time to detail. Remember this construction plane? With this construction plane, it's kind of like a sheet of paper. I can take this body. Did I say sheet of paper? Well, more like a huge knife. I can cut with this sheet of paper this geometry clock there. Because it's a flat surface, again, think about it, it's kind of like a plane which will be used to cut something. Okay. And I put this plane also just really below these arcs now. In case they start splitting also the arc, then we have to reglue these pieces back onto it. Or move the construction plane a tick lower. Very nice. So this is, for example, one material, and this is a different material or a different body. So right click, isolate. Take a look at the bottom. I'm going to show you how easy it is to create a very basic mechanism, how to snap two pieces together later. Because this is plastic, the rest is metal. We're going to extrude this one down 10mm, but as a new body. That's important. Click OK. And then, because this is a new body, I have these 4 sets of faces. We're going to offset them -1mm. And then we join this back together. You see, it's like a key. So, and this I can simply subtract from this. So from this, I subtract this one, keep the tool, yes, of course. Zip, there we are. No? Very easy. So we can simply, once this is manufactured, take this and clop, snap it in. Easy peasy. Cool. Let's go to the shell command, not tangent. Select this one, and then we say 2mm. Look, we can even get rid of interior material or excess material. 1mm. That's not working because this whole thing has 2mm material thickness. So 2mm for the shelling, and it cores everything out. And you saw I selected only the top face. Let's do this. Let's go to inspect, section view on this plane. There, you can see how beautifully this actually works. No? Everything in the inside got removed. If you make 2 million of these pieces, that's a lot of plastic you can save. Very nice. So I would say actually the top part is done. We can continue working with the base. Here we have, for example, a button. Let's make a sketch on this. No, we do not have to make a sketch. Maybe this is actually a good moment to give these sketches a name. And maybe base top. And then this is our arc and arc line. Okay, so base top. This is the one I would like to work with. Now where we have the rectangle on. Cool. Okay, right click and edit. Take a look at this. I go project and I project this, or doesn't matter, this edge in. Oh, actually I use this one because that's the inside. And now they have an arc. And because this is a G1 fillet, which is an arc, I also have a center point. Let's here make a circle, 20 millimeters. Thank you. And then we go to solid and extrude this up 4 millimeters as a new body for the moment. Very good. Okay. Now, for example, the sketch I can ignore and then maybe play with this. So what about if we make this 9 millimeters? Is this maybe better? Forward, backwards, forward, backwards. Maybe 8. So it's 16 millimeters. Yeah, this feels actually better. Before that sketch was, I find, a little bit too big. Or this one actually. So we have 9 millimeters. By the way, if we right click and show dimension on the sketch, I can go ahead and change this. 19, I think this is 18, no, there. So I can edit dimensions inside the sketch from the outside. Cool. Okay. No, that wasn't too bad. So this I can call button for the moment. Don't spend too much time on naming things because they can change a lot over time. Here, this one now I would like to select, right click and say isolate. Take a look from the bottom and then we go shell u 1 millimeter material thickness. Thank you. And now this is shelled. So pretty cool, no? So all the inside I don't model. You see also this transition here is modeled because we had these outside edges rounded. So now the inside edges will be rounded. Shelling simply takes the outside surface and offsets it to the inside, and then the volume in between there is being removed. Yeah, that was very, very easy. Okay, so might be time now to take a look at some interface design. So we have this front face here, no? And perfectly centered, I would like to put onto the openings for the USB and also the button we have. So this one. So this one here I will turn off for the moment, and then this button I will push down 2 millimeter just to make it a little bit bigger. Here I will round this by a millimeter. Thank you. And then I can say from you, remove this one, but keep the button. Thank you. So now this way I cut the hole because I had the geometry there. Here on this front face, we're going to create a sketch, and then I press P for project, and I can project this edge and I can project this edge in. So this is now really the top and the bottom. Oh, there you can see this. So on purpose, I'm going to draw everything a little bit crazy so you can see how great this system can work. So this is a vertical line. Click and drag, release, go to here, click and drag, and there. So now there we have actually this slot. Or I can also create drawing like this on purpose. This demo is more meant to show you how it's all the same. Arc and arc and arc and arc, and then some tangencies, and then hey, vertical, vertical. See, same thing. And in case drawing this by hand doesn't work, this is then the second way how you can do this. Okay, this whole thing here I will remove. Now I have this point. I can move this to here. And now what I want to do is center this design between here and here. I moved this over a little bit on purpose because I would like to show you something. From the midpoint, I draw a line. And here from the midpoint, I draw a line. These two lines, I will make construction and equal. And now I will say midpoint. So this point onto the arc midpoint and this point on the midpoint of this arc. Notice it is centered. Interesting trick to do the symmetry. Now all we have to do is make the width and the height. So point to point dimension. That is 8.4. Yeah, okay, that's interesting. That's not the way how this should have happened. Okay. 2.6. Let me do this maybe first. So 2.6 millimeters. There we are. And then from there to there. It gives us an that is interesting that it gives this issue. Right click and say tangent. So maybe we do dimension on the arc. Over constraint. This actually makes no sense. So I just deleted these lines. Right click, tangent, hue to hue, and it still does it. That is actually indeed quite interesting. D, right click, 8.4 there, and then U and U. Yeah, that makes no sense. So in case something like this happens, you can try to figure out how to solve it, or you do exactly what I did. You just redraw it. Trust me, that is sometimes the faster way. Cool. So D for dimension, 2.6, and right click tangent 8.4. Oh, look at that. It worked. Wah, wah. Welcome to Fusion. So we bring this over and then we do the same trick here, midpoint to midpoint, midpoint to midpoint. These two lines we make into construction and equal, suck. So because this is now dimensioned, you see it remains centered because of these two lines. Pretty cool, no? Yeah, I think so. Now, let's go back to our body. We have this opening. So this, now we can cut through. Yeah, there we have an opening. So there are now two ways how to continue more of these cuts. I could select this, make a new body, but or a new extrusion, but as a new body. And then this piece I move over by -6 millimeters now, and then say from you remove this one. Oh, but this tool I don't want. No? So this is kind of like we are solving this pattern via a part. If you have to make more pieces, so like 4 copies, now we can use the linear pattern. Or I can also go into the sketch, make a copy of this, move it over, and then constrain it. But I find with the sketching, that's a little bit more work. And honestly, with this method of making geometry left and right, that is actually very easy. So I do this piece one more time. There we are. And then this thing. So this body, we move over by 6 to the other side. And then I will, from this, remove this one. Keep tools, yes. Because here's another interesting thing. No, please move the whole body. There, thank you. Let's rotate it. Because at one point, we also want to have a USB-C opening on the top. So there, then I really needed to create a new sketch one more time, but you see, well, I can move this geometry piece somewhere else and just insert it and do that opening exactly the same way. It's a question of which is now the more professional or industrial standard method. I don't really care much about these sayings or ways of thinking because I think they're kind of more limiting. You should work in a way that is productive and fast. It's not about working hard or complicated. It's more about working smart and step by step building something up. Because we're in direct modeling, we can't make two sketches which we could link, but I have one sketch and I can move this piece out as a copy and position it perfect. And then later via direct modeling, if we need to adjust these fillets now with the push and pull, we can do that anyway, or move faces around. Cool. Anyway, so well, that's kind of cool. Okay. Let's go to the top here. And where is the top sketch? Yeah, this one. Maybe I call this USB. Edit. So here now we would like in the back to have a power outlet. This top piece is kind of in my way, so let's hide it. There we are. And we are going to sketch out this really interesting thing for an American power outlet. So 5 millimeter for this edge. There we are. Both edges should be equal. There we are. They're all vertical, horizontal. Then U and U can be equal. D, you are 2 millimeters. You are 9 millimeters. You are 7 millimeters. And how do we get this into a nice array? Check this out. Midpoint to midpoint. Midpoint to midpoint. Vertical, horizontal. This line, construction. Then this is actually 10. Okay. And I know that from here to here, this is 4. Cool. Well, this is just one way how to dimension it. Okay. So now if I select this, I can freely move this around. Now I would like to know maybe from this outer corner to the center, what is the dimension? So dimension from here to there. Okay, maybe one more time, maybe this line to this point. Let's see. There. That is 24. So you see how it moved it all over. And see here, this is actually the profile from the original box. So I don't have to project something in. Otherwise, I might project in this edge. I can say now that, for example, this edge to this edge is 14 or 13. It's up to you to define. Cool. Okay, very nice. And then here, 1, 2, 3. Come on, Fusion. Cut through. Thank you. Cite this. This actually is not correct. This is 5 millimeters by 5 millimeters, so we can round this by 2.5 with the fillet. And make a full round, half round, I mean. More American Power Outlet. Okay, how do we get this over to the other side? We can actually not mirror it only over because these pieces are standardized. So, what do we do? This is actually a great case here again to practice a little bit our drafting skill set. So, yeah, how can we get something done? One way, for example, is to think, so from here to the midpoint, how long is this? So this is 10 millimeters. Okay, then I draw myself another 10 millimeter line. So this is just from here over the midpoint to the other side, these two lines, no, the same. Cool. So this can be very useful because now I could say all this move up on purpose. Very good. Here comes the trick now. We select this body, this body, this body, and say point to point. And now we say from this outer point to here. So there it is. And then we can move this one down, or I'll actually go ahead and round these edges there. And then I move down, cut, zack, 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 done. Oh, I think I said keep tool. Oh, and delete those. You see? Easy peasy. So now this piece I would like to be perfectly centered along these two edges. Okay, now that's also very easy. So we go simply back to this sketch and then does this line up? Oh yeah, actually it does line up. So here I could project this edge in and then use the midpoint. But I know already here along the grid, this actually does line up perfectly. So here, this point I make horizontally constrained to the world origin. And then this should be there. Sometimes the dragging is kind of cranky. So, okay, in that case, let's project this edge in. Thank you. And then we say midpoint U to U there. This is a construction line. Thank you. So this is the midpoint. And now what we can do is we go ahead and say, move this body, but from the center to there. Thank you. And then that whole thing we move down and then cut it out there. You see, actually not complicated. And that's also why I said when you do this type of work, work in stages, work on copies. Here's all my form development, how everything started to look. This is actually quite nice. Step by step. Pretty cool. One thing I wanted to point out in direct modeling, this is actually really nice. You know, you can select a face and move this up, no? We can also select a face here and change this. or the whole thing we move around. Hold on 1 second. So this face and this face, we move, and you see how this actually moves the whole. It's actually the really nice part of this type of direct modeling. Very good. Okay, so I would say we are primarily done with blocking out most of the crucial elements. And our task now is to bring in the final details, so the USB component. Then we make a cable. Now we have to make an opening for the cable. Let's make the opening for the cable. That is here. There we are. Now a new sketch on that thing. Here's a line. I make a longer line and there. And then here from where's the midpoint there, I make a line down to their midpoint. And then this one I will vertically constrain. And this line is a construction line. Press X. Cool. This line will be 5 millimeters. And this will be 15. Then we can give this a nice circle at the center, 5 millimeters. We could round the edges here now, or do this later with the edge rounding fillet command. In this case here, to make life a tick easier, I'm doing this already right inside the sketch environment. I know very often I say, try not to do all this extra work when not necessary. But here, actually, in this case, it will make the task at hand a tick easier. So now we can go ahead, select this, and cut the hole out of the top part. See, it's gone. Then we will select this, extrude this -1 as a new body. Okay, and then this new body we join back to the bottom. Oh, there you see that. Oh, funny. Well. Yeah, this should go too. So now we have actually the opening for the cable to go through. Okay. Before we do the cable, the base needs to have a little bit of kind of like support or keys where the top part can snap onto. Let me show you how we can do this. Very simplistic way. So I make a new sketch on this, and then I press offset of this by -1. And that is the material thickness. Okay, thank you. Then I go offset this outer edge again, -2. Now our -2 or flip. Very good. There we are. And then I can go ahead and draw actually these lines in here. There we are. Because this whole design is a square, I'm only going to model this piece here one time. So say 2 millimeters as a new body. Very good. Thank you. And then we could do mirroring or circular pattern actually works perfect along this axis. 4 times sock there. And then all those join together with this one. Yeah, that's it, no? Clone. We could have sketched everything out, all the other corners, and modeled them, but this worked really good. Here maybe, let's do 0.5 of a fillet. Yeah, that looks good. Then I'm pressing on the Mac the Command key, or Windows, maybe that's the Control key. I'm filleting all these edges here. Also those. It just looks nicer. A little bit more refined, not so brutish. We did a cut in. And yeah, so you can hold the Command key, or I think Control Windows, and then you can add more edges to the selection. Yeah, that doesn't look too bad. Pretty cool. Okay. Cable. That's going to be interesting now. So we go to the top view. So yeah, I'm making a new sketch on purpose for this cable. I could have put this onto the sketch for the base. Then we will go spline, control point spline, and then somewhere in here, click, 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 click nicely in a line. So 4 points, and then, whoa, the cable somewhat moves out. Okay, so yeah, but class, that thing is flat. True, smart observation. Check this out. Now when I select these 4 points, and then I go to 3D sketch and press M, I can lift those up. See? And then all I want to make sure is that this is kind of like at the center where that circle is. And now you can also see why I made like 4 points in a line. Between the first 2 points, it's a straight line. Between the next 2 points, it's already arcing, then it's arcing more. So that's kind of like the whole point behind it. So I can bring this over, select this point, I can tighten this. Whoa, what's this? Rip. No. Okay, by the way, you can also select these edges or points, and with this, move this around. Sure. This is kind of like the way that how we can very easily sculpt, for example, a cable coming out. Cool. Okay. Now to make the cable, very basic suggestion. That's all we have to do. Pipe. Oh, where did it go to? There it is. 5 millimeters. No, as a new body. Yeah, and that's it. Yeah, it doesn't look too bad. It's kind of okay. Goodie. Now it's time to bring in the USB parts. So I just turned off or dissolved these features. I go to show data. I opened actually via open. Here is the USB part I downloaded. There is the 6-pin, the step file. That's the one you want. You can open. Takes a moment, and then you can save this. This is kind of like what I did. Now you see here I have 2 connectors, and then this right-click, insert into current design. Oh, we have to save first. Okay, yeah, let's save this. This is now Headphone Stand demo. Okay, so when it's saved, then we can insert it. There it is. There's one copy. I might have to rotate it. There we are. Thank you. Now select this. Now make a copy and rotate that copy. There. Cool. Okay. So what we can do now is I go move component point to point. So this component from for example, this edge or this edge. And then we snap this right onto there and hope this lines up perfectly. It's very close. There we are. We can now go and say component. This one as a copy. Let's do, this time we go from here, this edge to there. You see midpoint to midpoint. Sock. Did the same. There we can see it's a little bit off. It's all good. You guys are just learning how to do this, so I don't want you to get too crazy with things, because this type of precise working can really eat a lot of time. You see how I'm actually putting piece by piece over? By the way, this one I can hide just as an interesting alternative, because there are so many different ways how we can always do something. So maybe this component, this I would like to create a pattern along this direction, 3 pieces, and I think that it has to be 12 millimeter. Because you might remember we moved these 6 millimeter away from each other. Extend, or the spacing should be 6. Done. Did kind of like the same. Or not. There's 1. There's 2. What did the software do? There. 1, 2, 3, 4, 5. I'm not sure where that one went to. 6. Okay. Well, should have worked. Let's assume it worked. Cool. Also, you cannot delete this file now, because these are brought in. If we adjust this part adjusts too. So what we can do is we simply break the connection. Now this is not connected to the Fusion file we have inside our account. So if I would go and say delete, it wouldn't complain. Okay, very nice. Cool. So maybe a little bit of last touch up. You can press A for the materials. I have here a plastic. Then we can go to opaque. Maybe double click and then drag a yellow onto it. There we are. Beautiful. Maybe yellow for that one, yellow for the base, and then maybe a plastic or kind of like a metals based on what you want for the rest. One thing about materials, this black is way too dark, and we don't have to make it super bright, but if we make them very dark, the edges are hard to read. We make this a little bit brighter. Yeah, we know this is black, and it also is easy to read. Okay, perfect. There is our headphone stand. That wasn't too bad. I hope you kind of like started really seeing how simplistic 3D modeling is. I know this is all very simple geometry, cubes, circles, cylinders, etc. But how we started building everything step by step and then detailing it. This is a really important element for our students to understand, that this is the best way to get to a good result and not waste much time. And it's also a good creative tool, because then you can branch out. We could make a copy, change the colors. We could make copies, change the heights, proportions. We could make a copy with maybe with the power outlets minus the power elements. Oh yeah, since I mentioned power elements without, just so you see this. You can try this too. But you remember with the here we cut away the extrusion. When I select these faces and press delete, I get the original surface back. So that's the reason why I say in direct modeling, it's so easy to adjust everything and have multiples. Okay, enough of me. See you later.